All right, so you're prepping for that senior software engineer interview, right? And, system design questions. They're kind of the big leagues.
Yeah, those are the ones that really make you think.
Exactly. And a concept that keeps cropping up is event-driven architecture. It's like a core piece of building these modern scalable systems. So today, let's crack this open. What is it? How does it tick? And why is it such a big deal?
I think it's essential to be ready to not only define event-driven architecture, but to really dig into it. Like, what are the implications for your system? Where does it excel? And are there situations where it might not be the best fit?
Yeah.
That kind of deep dive is what really sets apart those senior candidates.
To be sure. So let's jump right in. Event-driven architecture. For someone coming from that, traditional request response world, what's the fundamental shift in thinking?
Okay, so in the request response model, it's all about direct communication, right? Service A asks Service B to do something, waits for a reply, then moves on. But event-driven architecture kind of flips that script.
Oh, interesting. How so?
Instead of directly asking, a service announces that something's happened. It emits an event, a signal that something in its domain has changed. Like, hey everyone, this just went down.
So less of a back-and-forth conversation and more like a broadcast message.
Yeah, exactly. And the key thing here is it's asynchronous. The service that emits the event, it doesn't hang around waiting for a response. It just sends the signal and keeps going. Any services that care about that event, the listeners, they process it on their own time.
Gotcha. So what exactly constitutes an event in this context?
Basically, an event is a statement of fact. Something happened, a state changed, an action was completed. And the cool part is the service sending that event often doesn't even know who's listening. It's just responsible for getting the message out.
Can you give us a real-world example? Something concrete to help visualize this.
Sure, think of an e-commerce site. When orders package up in the warehouse, that service might emit an order packaged event. Now, other parts of the system, like the notification service, it would be tuned in to that event. It hears order packaged and boom, sends out a shipping confirmation to the customer.
Makes sense. And I guess the inventory service would be listening too, right? To update stock levels and all that.
Right. And that's the beauty of it. The warehouse doesn't need to know or care about those other services. It just announces order packaged and lets them figure out what to do.
It seems like you need a way to manage all these broadcasts and who's listening to what, right? Is that where publish subscribe comes in?
Exactly. Publish subscribe or PubSub, it's kind of the bread and butter of event-driven architecture. It's that mechanism that lets services publish events without needing a direct line to each subscriber.
So the warehouse and customer service, they would be the publishers in this scenario.
Yeah, the warehouse for the order packaged event. But, a customer service might publish a customer address updated event. And then maybe shipping, billing, even marketing, they'd all be subscribed because they care about that change.
Wow, so the customer service doesn't have to keep track of all those downstream services. That's pretty powerful.
Right. It's all about decoupling. Publishers and subscribers are independent. It's a one-to-many relationship, one event, multiple potential listeners.
And that must be where the scalability and resilience benefits come in, right?
Totally. Imagine you add a fraud detection service that needs to know about every order. With PubSub, it just subscribes to the order-placed event stream. No changes needed on the order service side.
It just plugs right in.
Exactly. And if, say, the notification service has a hiccup, the events are still being emitted. When it's back up, it catches up on what it missed. The system as a whole keeps humming along.
So let's get into the nitty-gritty of the events themselves. What kind of information goes into an event? Is there a best practice here?
This is where it gets interesting. There are different schools of thought. Some folks advocate for lean events, just the bare minimum. Like if a new customer registers, the event might only contain their ID.
Just the ID. Why so minimal?
The idea is to keep events small and avoid coupling the event structure to every single potential consumer. But here's the catch. If a service like notifications needs to send a welcome email, it only has the ID. It has to go back to the customer service to get the name and email.
Ah, so you save on event size but end up with more back and forth chatter.
Precisely. Plus, you're now creating a dependency between those services, which is not ideal. And if multiple services need those extra details, you're suddenly hitting the customer service with a ton of requests.
Not very scalable, huh? So what's the other side of the coin?
Richer events. Instead of just the ID, include the name and email right in the customer registered event. Notifications has everything it needs right there. No extra calls.
Streamlined. Does this apply to like our loyalty program too?
Absolutely. If they're subscribed, they can grab the name and set up the account without any additional requests. Richer events mean looser coupling because the services are more self-sufficient.
Interesting. But aren't we sending more data than some services might need?
That's a valid concern.
Hmm.
You have to think about event size and data visibility. Modern message brokers handle larger messages well, but do you want, say, the loyalty service to have the customer's email if it's not strictly necessary?
Yeah, data privacy is a big deal, so how do you strike that balance?
One option, though it adds complexity, is different event types with varying levels of detail. A basic customer registered with the ID for general consumption, and a customer profile created with more info for specific services that need it.
So choosing the right event structure is crucial. Is there a good rule of thumb to follow?
Here's a helpful guideline. If you'd be comfortable sharing that data through an API in a normal request-response scenario, it's probably okay to include it in the event. Think about what's appropriate to share and the impact on your system's coupling and data privacy.
Makes sense. Okay, so we have events, we have PubSub. How does this all actually work in a real system? How do these events get around?
The most common way is using a message broker. Think RabbitMQ or Kafka. They're like central hubs that handle event publishing, subscriptions, queuing, and persistence. Designed for high volume and reliability, but they add another piece of infrastructure to manage.
So powerful, but maybe a bit more complex to set up. Are there alternatives?
Sometimes you can leverage HTTP, like services publish events to an Atom feed, and consumers periodically check it for new stuff. It's simple and uses familiar tech, but might not be great for low latency needs, and consumers have to keep track of what they've processed.
Each approach has its pros and cons.
Exactly. And no matter what you use, try to keep the middleware, the brokers, or whatever you're using relatively simple. The real brains of the operation should be in your microservices, in the code that handles emitting and consuming the events.
Right. The middleware is just the delivery mechanism. It's the event itself that holds the valuable information. So putting it all together, when is event-driven architecture the right choice for a system? What are the signs?
When you need to broadcast info to a bunch of independent services, it's a winner. If many parts of your system need to react to the same thing happening, event-driven architecture can be elegant. Also, when you want to invert intent, instead of telling services what to do, you just announce a change and let them figure out their response. And of course, if loose coupling and service autonomy are top priorities, event-driven architecture is a strong contender.
But I'm guessing it's not a magic bullet, right? There must be situations where it's not the best fit.
Oh, definitely. It comes with its own set of challenges. Debugging a system built on asynchronous communication can be tricky. Managing event schemas as things evolve requires careful thought. And if your team is new to the concept, there's a learning curve. You also don't have to go all in on event-driven architecture. A hybrid approach, mixing it with traditional request response, is often a good starting point, especially when you're getting your feet wet.
A hybrid approach, I like that. Start small and scale up as you gain experience.
Exactly.
This deep dive into event-driven architecture has been really insightful, especially for anyone gearing up for those senior-level interviews. So let's recap the key takeaways. We talked about the asynchronous nature of it all, the importance of PubSub, how the design of your events, whether lean or rich, has huge implications, and the choices you have in implementation.
And remember, being able to clearly explain these concepts, weigh the pros and cons, and tie it all back to real-world examples, that's what interviewers look for in a senior engineer.
Couldn't have said it better myself. And on that note, here's something to ponder as you prep for those interviews. Think back to systems you've encountered, maybe in your work or in case studies. Where could an event-driven approach have really shined? And just as important, what potential challenges do you foresee in implementing it in those contexts? Thinking through these real-world scenarios will not only deepen your understanding, but also give you some great talking points for that next interview. Thanks for joining us.
It's been a pleasure.
Until next time.
See ya.